be talking about Lab 1, the charge tapes. To introduce, I used two key concepts for this lab. One was Newton's second and third law, and the other was Coulomb's law and the idea of charge. The purpose of this experiment was to help us visualize how charged objects affect each other in the real world and how gravity and electrostatic forces act together on objects. Firstly, on the U-tape interaction bit, the U-tapes repelled against each other as the charges on them were like, and the U-tapes were attracted to U-tape was attracted to the neutrally charged object due to the concept of charge separation. When a U-tape is taken close to a neutrally charged object, a charge separation takes place on the neutrally charged object, and the charge which is opposite to the charge of the tape is to is to moves towards the end of the object where the tape is placed. And assuming that the pen is negatively charged, the positively charged U-tape should be attracted to the pen as their opposite charges and opposite charges attract. Moving on, the data from the experiment was the length of the tape was 20 centimeters, the mass of the tape was 0.0002 kilograms, and the floating distance, which is the distance between the tapes when their charge was about 0.09 centimeters. The assumptions I used for this experiment was I ignored air resistance, treated the long tape as though it were a point charge, and assumed that each tape had about the same charge and was evenly distributed. The calculations were as follows. The electrostatic force using the formula kq1 q2 over r squared can be seen here, and it can be rewritten as this because their charges are identical, so it becomes q squared instead of q1 q2. The gravitational force from Newton's second law is mg, which is this, and as per Newton's second law, the net force on the system is zero. That is, the system is in equilibrium, so the forces have to be equal. Using that concept, I equated the forces and made q the subject, and this is the value of q I got from the program I ran. To calculate number of excess electrons, I basically just divided the excess charge by the charge of one electron to get the number of electrons on the tape. And for the fraction of atoms that gave up electrons, I took the ratio of the number of atoms and the number of electrons, and the ratio came out to be 1 is to 13.17. To answer the questions that were on lab 1, what if the electrons had a positive, for the first question, had a positive charge and the protons had a negative charge? It would be exactly the same, as opposite charges would still attract and like charges would still repel. The designation of charges as positive and negative is merely a definition. And why is it important to not handle the tapes as is to avoid the grounding of charge, which happens when the tapes come in contact with other objects. Here's my code for the experiment. These are the main two forces defined here. These are the constants I've used, and the main two forces, as you can see, the electrostatic force is just the absolute value of the gravitational force. It's because there are two forces which of equal magnitude acting in the opposite directions. The r is the vector from the particle to the observation location, from the particle to the observation location, and here's the formula which I derived a couple of slides ago. And here's the formula for the number of electrons, which I explained on the previous slide. And I used spheres to represent each tape. The sphere, this can be seen as the upper tape, and this can be seen as the lower tape. The yellow arrow is the force of gravity, and the green arrow represents the electrostatic force. Notice how the yellow and the green arrow are the same in length, but in opposite directions. That shows the system is in equilibrium. The charge on the tape is 4.2 into 10 to the negative 9, and the number of electrons, as shown on previous slide, is this. To conclude, the experiment allowed me to visualize the effects of attractive and repulsive electric forces using the idea of gravitational objects and electrostatic forces being equal and in opposite directions. Using this idea, I was able to calculate the excess charge on the tape, and from that, the number of excess electrons were found. Thank you.